Hello, my dear friends. Myself is Rajesh S. Wadhwani. I am registered valuer in land and building asset class. Today we are starting statistics. This covered 2 marks as per IBBI new syllabus. It covered data classification and processing, graphical representation of data, frequency distribution, measure of central tendency, dispersion, and skewness. Elementary theory of probability and probability distribution, sampling and sampling distribution, sample test of significance, regression, correlation, multiple correlation coefficient, time series, index number. First, we will learn definition and purpose of statistics for valuer. Statistics is the study of how to collect, organize, and understand data to help better decisions. Purpose of learning statistics. Statistics helps valuer organize property and plant and machinery data related. Second, summarize and simplify large amount of information. Third, analyze the data to find useful pattern and insight. How is statistics useful in property and plant and machinery valuation? Statistics play an important role in both property valuation and plant and machinery valuation. It helps valuer collect, understand, and explain data to make correct and confident decisions. Key benefit of using statistics in valuation work: understanding the market trends, comparison of similar assets, risk and uncertainty analysis. You can do it. Valuation method you can decide with the help of available data and clear presentation of reports. You make the evaluation report with the help of statistics data by using tables, graph, chart for better understanding, make report more professional and reader friendly. Key concept in statistical data. There are first is called raw data, primary data, secondary data, statistical data. Raw data. Raw data means information collected it in original form. Whatever information you have collected and you have written, that information data is called raw data. Just as you observed or recorded, not yet sorted. आपने उन डाटा को सॉर्ट आउट नहीं किया है, ग्रुप में नहीं किया है, तो जैसे आपको डाटा मिले हैं वैसे रिकॉर्ड किया है, वो कहलाता है रॉ डाटा. प्राइमरी डाटा. Primary data. Data collected directly by the valuer or researcher for specific valuation purpose. आपका जो पर्पस है उसके लिए जो डाटा कलेक्ट किए हैं आपने, वो डाटा कहलाते हैं प्राइमरी डाटा. Secondary data. Already existing data collected by other but useful for your valuation work. Government reports, published rates, yeah, you have collected per square feet rate from the agents or revenue office. You have collected the rates. That's already data is having. They are having the data. You are collected from them. That is called as secondary data. Statistical data. Data obtained by counting and measuring. Used for analyzing trend or making decision. It may come from primary or secondary source. आपके पास primary और secondary source से जो डाटा आए, उन डाटा से आप किसी निष्कर्ष पर पहुंच रहे हैं, वो डाटा स्टैटिकल डाटा कहलाते हैं. जिससे कि आप कोई डिसीजन ले सकें। तो टाइप ऑफ डाटा टू टाइप्स रहते हैं, एक क्वांटिटेटिव डाटा रहते हैं, दूसरा रहते हैं क्वालिटेटिव डाटा। क्वांटिटेटिव डाटा नंबर्स में रहते हैं, क्वालिटेटिव डाटा नॉट नंबर्स में नहीं रहते। और क्वांटिटेटिव डाटा अगेन डिवाइड हो जाते हैं डिस्क्रीट डाटा एंड कंटिन्यूस डाटा, एंड क्वालिटेटिव डाटा डिवाइड हो जाते हैं कैटेगरिकल डाटा। डिस्क्रीट डाटा में नंबर ऑफ स्टूडेंट, नंबर ऑफ एम्प्लॉय। कंटिन्यूस डाटा हाइट ऑफ पीपल, डेली टेम्परेचर, ये सब कंटिन्यूस डाटा में आते हैं, डेली रेनफॉल। और कलर, हेयर कलर, आई कलर, ये सब क्वालिटेटिव डाटा में आते हैं। तो टाइप ऑफ डाटा आई एक्सप्लेन यू क्वालिटेटिव डाटा एंड क्वांटिटेटिव डाटा। Qualitative data describe characteristic quality features or attribute. Example, hair color, education level, property uses, residential, industrial, building type, machinery category, soil type, all is coming qualitative data. In quantitative data, expressed in numbers, measurable or countable. Subcategory, discrete, countable value, number of students, number of rooms, number of floors. Continuous, measurable value, height, weight, land area, machinery weight. It is coming a continuous data. It's part of quantitative data. Categories versus numerical data. हिंदी में कहेंगे कैटेगरिकल डाटा को श्रेणी आधारित डाटा, किसी कैटेगरी के अंदर में आते हो। इसके हेयर का कलर ब्राउन है, ब्लैक है, वो सब कैटेगरिकल डाटा हो गया। न्यूमेरिकल डाटा जिसको संख्यात्मक डाटा रहे। कैटेगरी डाटा रिप्रेजेंट कैरेक्टरिस्टिक्स। नॉमिनल दो टाइप के होते हैं, एक नॉमिनल, दूसरा ऑर्डिनल। नॉमिनल अनऑर्डर्ड लेवल, जैसे एग्जाम्पल जेंडर, लैंग्वेज, लोकेशन। Ordinal, ordered level, education level. You have done education primary, middle level, secondary, higher education, graduation, post graduation, and doctorate. Is coming original data. Numerical data and always in numbers, interval, ordered unit with equal interval, no absolute zero. Other ratio, ordered units with equal interval and an absolute zero, height, weight, area, cost, age of buildings. Second point is classification of data. Data is classified, basis of classification can be classified qualitative basis, quantitative basis, also can be classified geographical basis, country basis, state-wise basis, district-wise basis, and chronological basis. 15th century, 17th century, 20th century, 21st century, year wise, based on time basis. Type of classification, one-way classification, only group for one factor. Your classification of building, that is called a one-way classification. Two-way classification grouped by two factors, building type and location. Third, multi-way classification grouped by three and more factors. Steps in data classification. First, you collect the data. Data collection, gather raw data from various sources. Defining levels, set category like location, type, value, range. Then you define it, which data is there. Grouping into category. Then after that you do groupings. Arrange data according to defined characteristics. Labeling and tabulating. Create tables, row and columns to organize the data. Next, how to data processing. You have collected the data, then done a grouping, labeling, and tabulating. You have done it now. Next is data processing. Data processing is the process of converting raw data into useful information by using different steps. Stages of data processing. First, you collect collection first, then pre-processing, In pre-processing, cleaning, removing errors or duplication, storage, saving in computers, register or spreadsheets. Then you processing, using software tools to calculate, analyze and sort out, sharing and use, preparing reports, graphs or presentation, archiving or deleting for record keeping or secure removal. Benefit of data collection and processing. Benefit and improved clarity helps understand the data easily and quickly. Better decision making supports selection of valuation approach. Time saving group data is faster to analyze. Professional reporting make valuation report easy to read with visuals. Risk reduction well processed data avoid error in the conclusion. This was data collection, data processing. We have learned as per the syllabus. Data classification and processing. Now we will learn graphical representation of data. And after that, frequency distribution. Graphical representation of data. Graphical representation simplify the understanding of data by visually illustrating relationship, trends, and distribution. With graphs, you can understand the data easily. Why use graphs and chart in valuation? Graphical representation of data is visual method of presenting numerical and categorical information. It helps valuer, clients, and stakeholder to quickly understand trends and comparisons. Interpret large volume of data clearly. Make data-driven decision in property or machinery valuation. Showing data using charts, diagram, or pictures another way to make information easier to understand. It helps simplify complex information and enhance clarity. आप ग्राफ्स और चार्ट से इजीली समझ सकते हैं. टाइप ऑफ ग्राफिकल representation. We will learn bar chart, pie chart, histogram. Symmetric histogram, skewed right side histogram, skewed left side, positive skewed or negative skewed, and polygon. Polygon में we will learn normal symmetric polygon, positive skewed, negative skewed, and ogive. Ogive means cumulative frequency curve. We will learn less than ogive and more than ogive. First, we will start with the bar chart. Bar chart you have learned in your engineering college. Bar chart definition: a graph made of bars whose height is represent the frequency of respective category. Ideal for comparing data across categories such as survey result, performance, preference, and demographics. Features: bar can be vertical or horizontal. Spacing between बार distinguish categories. बार्स के बीच में स्पेस रहना चाहिए. Pie chart. Pie chart is a circle chart. A circle divided into portions that represent the relative frequency or percentage of population or sample belonging to the different categories. Effective, effective for showing proportionate of parts of a whole. Features: the circle represents 100% of the data. Each slice corresponds to category and is sized based on its relative percentage. So you know the bar chart. This is the bar chart. This is as per budget. Agriculture budget is 12,000 crores. Industry is 20,000 crores. Infra is 50,000 crores. Railway is 60,000 crores. Military is 90,000 crores. This budget how to show in the bars. This is the so on X axis you put the agriculture, industry, infra, railway, and military, and here vertical axis is the value 10,000, 20,000, 30,000. So you can see maximum budget allocated in military, after that railway, then infra, then industry, and minimum in the agricultures. Now the same data can be shown in the pie chart. In pie chart, agriculture, industry, infra, railway, and military, same figure. And so in pie chart, we can show in pie chart, it will come in the percentage also. Military 39%, agriculture 5%, industry 9%, infra is a 21%, railway is a 26%. This is a bar chart and pie chart. Now, before moving histogram, first we have to learn frequency distribution. What is the frequency distribution? A frequency distribution is a table that shows each value or range of value, group or class, and how many times frequency it appear in the data. It helps to organize, summarize, and analyze raw data. Or we can tell a frequency distribution is a way of presenting data in table format, showing how many times each value or group of value appear in the data set. Let's do one example. Marks scored by 10 students. Raw data 45, 50, 50, 60, 60, 60, 70, 70, 80, 90. So we one column we write the marks 45, 50, 60, 70, 80, 90. 45 got by one student, 50 got by two students, 60 got by three students, 72, 80, one student, 91. So this will become a frequency. This is called a frequency. How many times mark scored by the student? 50 is the two students, 60 is the three students, 70 is the two students. This is the frequency. Up this frequency added to next class frequency, next mark, that will become a cumulative frequency. 45, 1, 52. So 50 cumulative frequency is a 3, means up to 50 marks, 3 students got the marks. One student got 40 and two student 50. Then 3 students got the marks. 60 cumulative frequency is 6. 350 3 frequency up to 50 and 3 for 60. So total 6. Up to 60 marks, 6 students got the mark. The 6 is the cumulative frequency. 70, 2 students. So 6 plus 2 become a 8. 8 is the cumulative frequency. 8. 80 marks. 1 plus 8 become a 9. 90. 1 plus 9 become a 10. So this is the cumulative frequency. And relative frequency. Relative frequency, total frequency is the 10. 45 marks is 1. So 1 divided by 10 into 100. That is a 10%. Relative frequency. 50 for marks 50 is a 20%. Marks 60, 30%. 70, 20%. 80 marks 10%. 90, 10%. Total relative frequency is the 100%. How to calculate relative frequency? Calculated frequency divided by total observation into 100, and cumulative frequency you already calculate sum of all frequency up to that row, sum of all the frequency up to that row, that is the cumulative frequency. So type of frequency distribution, two types of frequency distribution. One is ungrouped frequency distribution, that is the individual student marks, so that each individual value in its frequency used when data is small and exact, as in the example above. Group frequency, when number of student is more, 200 student, 500 student, 2 lakhs, 5 lakhs, 30 lakhs, 1 crore, then we will make a group frequency distribution. The 40 to 50 marks obtained by one student, 50 to 60 marks obtained by two students, 60 to 70 marks obtained by three students, 70 to 82, 80 to 91, 90 to 1 is a one student. Discrete frequency distribution data take specific separate value number of machine houses used in valuation for plant and machinery or buildings. Relative frequency distribution show proportionate or percentage instead of actual count. Helps in comparing different data set. Cumulative frequency distribution show the running total of a frequency useful for finding. If you are having the cumulative frequency, you can find median, percentiles, and graphs. You can draw the graphs. Relative cumulative frequency optional. Cumulative frequency as a percentage of total observations. Now do the example. Prepare a frequency distribution table for the following data and explain its component. Raw data is given this. Total data is 18 numbers. First, you put data in ascending order or descending order. Preferably, you first put all the data in ascending order. After putting the data in ascending order, decide class width. Here, range minimum data is 2 and maximum data value is 16. Data vary from 2 to 16. So, we have decided four class 1 to 4, 5 to 8, 9 to 12, 13 to 16. Then 1 to 4, 1 to 4 total 5 frequency 2, 2, 3, 4, 4 up to here 5 times is repeating. It is coming in 1 to 4 class 5 frequency. Next class is 5 to 8. 5 to 8 is coming 5, 6, 7, 7, 8 5 times. Then next class is 9 to 12. 9 to 12 is coming 9, 11, 12, 12, 4 times, 4 frequency. Next class is 13 to 16. 13 to 16, 4 datas. The frequency is the 4. Total frequency is the 18. Now with this frequency, we can calculate the relative frequency. Total is 18. 1 to 4 class relative frequency 5 by 18, that is 28%. Second 5 to 8, 28%. 9 to 12, 4 by 8, 18, 22%. And fourth class is 13 by 16, 4 by 18, 22%. This is the one. Now, accordingly, we can calculate from this data cumulative frequency. 1 to 4 cumulative frequency is 5, 5 to up to 5 to 8 class cumulative frequency 10, 9 to 12 class cumulative frequency is 14, 13 to 16 class cumulative frequency is 18. Now, in this example is asking explain its component. So we will explain all the component in the tabular form. First is class A, range of grouped value. So we have divided this class in four groups 1 to 4, 5 to 8, 9 to 12, 13 to 6. This is the class. Class limit, the lowest and highest value in the class. 1 to 4, lowest value is the 1, highest value is the 4. Then class limit 1 to 4. Class width, difference between lower limit of two consecutive class. First class lower limit is 1. Second consecutive class is the 5 by 8, lower limit the 5. 5 minus 1, the difference is the this is called a class width. 5 minus 1 is equal to 4. Then the mid value, average of lower and upper limit of class. Here 1 to 4. 1 to 4 mid value 1 plus 4 divided by 2 is the 2.5. Next class mid value 5 to 8. 5 plus 8 divided by 2. 13. 13 divided by 2 is the 6.5. Accordingly, you can calculate 9 to 12 class mid value and 13 to 6 class mid value. add both of this and divide by 2. Then class frequency, number of data value in each class. For example, 5 to 8 frequency is the 6. Relative frequency, frequency divided by total items. So proportionate 6 by 18 is 33%. Cumulative frequency up to that class total frequency. Total of frequency from the first class up to the current one. For 9 to 12, cumulative frequency is the 14. Why use frequency distribution in valuation? Helps valuer organize large data set like sales price, asset life, rent value, etc. Make it easy to find most common value, trends, and outliers. Useful in report preparation, analysis, and charts. This is the frequency distribution. Now one more is the measure of central tendency. A measure of central tendency is a number that shows the center or middle value of set of data. It tells us what is the typical value in the group, what is the central location value in the group. It also called measure of central location because it shows where most of the value are gathered. Why is it useful? It helps valuer and analyst to understand what is the average or most common value. Compare data easily, take better decision using summarized data. There are three most common measures are mean, median, mode. For calculating central tendency, three main most common measure mean, median, mode. Mean the average, add all value and divide by the number of valuer. Median, the middle value when data is arranged in order. Mode, the value that appear most often. Mean, mean is the average. The mean is the sum of all value in data set divided by the total number of value. All the data set number is first you add it and divide by total number data. Sum of all the observation mean. How to calculate mean? Sum of all the observation. Total number of observation. Best for evenly distributed data set without extreme value. When data sets are evenly distributed, then mean is the best of central tendency. But data should be equally eventually distributed as it is sensitive to outliers. If any data is last data or first data is a maximum or minimum, then mean is the not the best value. We will see with the examples. Median. The median is the middle value of ordered data set. Whatever data set is given, first you put in ascending order, then select the middle number. That is the called a median. The median is middle value. Median is the when odd number. When data is total 9 say 9 data. So we can calculate a median n plus 1 divided by 2, 9 plus 1 divided by 2, 10. The here coming 5. The fifth value is the median value. The median is the average of two middle value. Average of the two middle value if data are the even numbers. If data are the 8, data are the 8, it can be calculated n by 2, 4 plus second n by 2 plus 1. fourth and fifth number will be the median. Now fourth number and fifth number, add this and divide by 2. Whatever average will come, that will be the median for even numbers. Median value at n by 2 plus value n by 2 plus 1 by 2. Useful for data set with skewed value or extremely outliers. We will understand this with the example. As it is unaffected by them, if any outliers, yeah, maximum data or minimum data, it will be unaffected. Mode, the definition. The mode is the value that appear most frequently in data set. If you take the height of 10th class student, the height may be 4 feet 5 inch, 4 feet 6 inch, 4 feet 7 inch, 4 feet 8 inch, 4 feet 9 inch. Only this 5 to 6 category height will be there, which is the most frequently. Say 4 feet by 7 inches. The more student out of 20 student, 7 student is the 4 feet by 7 inch. Then 4 feet by seven student there 7 will be the mode of this is most frequently appear maximum time appear in data set is the called a mode. Ideal for categorical data when identifying most common value in important. All three we will learn with the example. We will calculate the mean, median, and mode for the data set. Data set is given 300, 10, 10, 20, 30, 50, 60. The total numbers 1, 2, 3, 4, 5, 6, 7. Total observation is the 7. Now, first we will put this data in ascending order or descending order. You can put it data 10, 10, 20, 30, 50, 60 plus last month you can here add it 300. This is ascending order. 10, 10, 20, 30, 50, 60 plus 300. Uh, Calculate the mean sum of all this 10, 10, 20, 30, 50, 60 plus 300. It is 480. Total number of observation is 7. So calculate the mean value. Mean value is the 480 by 7. It is coming 68.57. It is coming 68.57. If you see this data set in ascending order, 68.57 is the not the middle. This is not correctly measure the central tendency in this example. Not correctly central tendency due to one value is the 300. Due to 300 value that is outlier, not as per this series. Due to this mean is not calculate as per central tendency. Middle value should be approximate a middle value. So here mean is coming 68.57. Now you calculate mm, uh, median. Arrange the data in ascending order 10, 10, 20, 30, 50, 60, 300. Here total number is 7. This is the odd number. Odd number means n plus 1 divided by 2. 7 plus 1 divided by 2. It is coming fourth number. The fourth number 1, 2, 3, 4. 30 is the median. The fourth value is the 30. The median is 30. So this 30 give a correct result, correct central of tendency. correct center point. The median in this case, if data is not evenly distributed, the calculating median give the correct central tendency, measure of central tendency. Now you calculate the mode. Mode is the most frequently is coming. So here in data set, ascending order, put it 10 coming 2 times, 21 times, 31 times, 51 times, 61 times, 300 is 1 time. The value of highest frequency is the 10. So here mode is the 10. So we found result mean 68.57, median is 30, mode is 10. The mean 68.57 is higher than the median because of the extreme value. Why it is coming mean higher than the median? Because of one value, that was the 300, that is called the extreme value in the data set, which skew the mean. Due to this data set, all is skew going to one side. The median is the better representation of center in the case, as it is unaffected by extreme value. If extreme value 300, say it may be 1000, 2000, the median will unaffected. It will give a central value. Mode identify the most frequently occurring value 10, providing insight into dataset repetition. So we can tell mean is good for eventually distributed dataset. Median for skewed or uneven data set. If value is the 0, 0 also, and then marks is 40, 50, 60, 80, then also calculating median is the good, it will give a correct central location. Mode for categorical or survey data. Both are repeating. Now exercise number 1. Please do this exercise. You pause the video for 5 minutes and solve it. This question came in my examination, in IBBI examination. It's asking calculate the missing term in the series 5, 12, 18, 25. One term is the missing. Calculate the missing term where the mean is given 20. We know the formula mean is the sum of all the observation divided by total number of observation. So 20 into 5. The mean is 20, sum of all the observation 5 plus 12, missing observation says the x plus 18 plus 25 divide by 5. Here mean 20 into 5 plus you add 5 plus 12 plus 18 plus 25 is coming 60. So 100 minus 60, the missing value is the 40. The mean is 40. Now is asking in second exercise, same data series. You calculate median and mode. We know the x value 5, 12, 40, 18, 25. First, put this data series into ascending order. It will value 5, 12, 18, 25, 40. Total 5 number data. So odd number mean is the n plus 1 by 2, 5 plus 1 by 2, 6 by 2 is the 3. So third value is the median value. Here third in ascending order, the median value is the 18. Third number is the 18. So median is the 18. Calculate the mode. Here no number is repeating. So mode is the nil. So there is a no number repeating. For mode, number of repeating must 2 times, 3 times, whatever times. If it is 2, 5 plus 5, 12, 18, 25, then mode is the 5 because it is repeating 2 times. In this example, no repetition and mode is the nil. No mode, zero mode. Now you have to learn only formula. geometric mean, harmonic mean. Geometric mean, the geometric mean is the average of a set of positive number calculated by multiplying them together and then taking the nth root, where n is the total number of a value. It is particularly useful for data that involve growth rates, ratio, or percentage. The geometric means this is you can calculate it. X1 multiplied by X2 multiplied by X3 into number of data Xn. Then you take the root of nth. Harmonic mean. Harmonic mean is the measure of central tendency that is the reciprocal of arithmetic mean of reciprocal of given value. It is used when dealing with the rates or ratios such as speed or efficiency. The formula harmonic mean formula is n divided by 1 upon x1 plus 1 beta x2 plus 1 upon xn. You remember this formula. And relationship between arithmetic mean, geometric mean, and HM. Arithmetic mean always greater than or equal to geometric mean. Geometric mean is always greater than or equal to arithmetic mean. And relationship is this: GM AM root into HM root. This means the arithmetic mean is always greater than or equal to geometric mean. Geometric mean is always greater than or equal to harmonic mean. Equally holds if and only if all the number in the data sets are equal. Next topic is a dispersion. डिस्पर्सन को हिंदी में फैलाव बोला जाता है कि कौन सी चीज कितना फैली हुई है. Dispersion means how spread out or scattered the value in a data set are. हिंदी में ये दर्शाता है कि डाटा कितनी दूर दूर या पास पास बिखरा हुआ है या फैला हुआ है. It shows how much the value differ from the average, mean, median or mode. Mean, median, mode से other data कितने spread हैं. Also known as a spread, scatter or variation. Why dispersion is important? Helps understand consistency in data. Two data set may have the same average but have different spreads. Crucial for property valuation, plant and machinery, and risk analysis. Key concept: all value are same. It means no variation. 100, 100, 100. All students got 100, 100, 100 marks. So dispersion is 0. Slightly different value. Low dispersion. 98, 90, 100, 101, 102, or say 97, 96. In this case, dispersion from the mean is very low. One very different value. High dispersion. Say data set are 1, 2, 3, 4 and 490. If median is the 3, median is 3, then 490 is a far away from the value from the 3. Here the high dispersion. Or we can tell if all students in class have the same mark, then the dispersion is 0. If there is a large difference in marks among the students, then the dispersion is the high. Graphical understanding of dispersion. This is the graph. Curve A. Curve, you see curve A is the in blue color. All data sets are very near. So very narrow and low dispersion. B is marked green color. data sets are some spread. We can say medium spread by B. Curve C in red color. If you see data uh, place very wide range. So here the high dispersion. Conclusion: dispersion helps in understanding how value are vary around the center. From center, how the value are varying the left side and right side. Mean alone is not enough. Dispersion tell the full story of the data set. Mean alone is not enough. Dispersion tell the full story of the data set. Essential in statistics for fair comparison, decision making, and analysis. This is the dispersion. Now we will understand the histogram. A histogram is a graphical representation where classes are on horizontal axis. In horizontal axis, class will be marked and group will be marked. Frequency, relative frequency or percentage are on the vertical axis. Bars are drawn adjacent to each other. These bars are drawn to adjacent to each other, showing the frequency of data within each class. There should be no gap between the bars. If there is a gap between the bars, it will become a bar chart. If there is no gap between the bars, so it will become a histogram. Class or group on x-axis, frequency, relative frequency, cumulative frequency on y-axis. So here I have drawn a histogram. Class 0 to 10, 2 run, 10 to 20, 4 out, 20 to 35 by 2 teams, 30 to 44, 40 to 53, and 50 to 62. So from this table, I have prepared this a diagram. This is the histogram diagram. Now one is what is the polygon? Definition of frequency polygon. A frequency polygon is a graphical representation of frequency distribution. It is created by joining the midpoint of the top of each histogram bars with the straight line. It visually represents how data is distributed across different interval in group data. This is the polygon definition. We will understand with the diagram. And one more term is there, polygon curve. A polygon curve refers to smooth line graph formed by connecting the midpoint of class interval. If the midpoint are connected using curve line instead of straight segment, the graph may be called a smooth polygon curve. This is a more common descriptive statistics when a smoother appearance is desired. So here I am explaining polygon and polygon curve. If center point of each class on the histogram, this is the center point, this center point, center point, center point, center point, center. If center point of each histogram of each class joined by a straight line, this is called a polygon curve. Sorry, this is called a polygon. Polygon. Now this midpoint Join with the curve, with a smooth curve. Join with the smooth curve to look better. Join with the smooth curve all the points. Is called a polygon curve. This is the polygon curve. Green color is the curve, red color is the polygon. If histogram every class midpoint joined by the straight line, that is the polygon. If midpoint joined with a curve, smooth curve, then it is called a polygon curve. Hope it is the clear. Definition is the same. A frequency polygon is a graphical representative of frequency distribution. It is created by joining the midpoint of the top of each histogram bar with the straight line. If joining with the straight line top of midpoint of histogram, it will become a polygon. We can tell also frequency polygon. If the same histogram midpoint join with the, if the midpoint are connected using curved lines, using instead of straight line segment, the graph may be called smooth polygon curve. This is a more common descriptive statistics when a smoother appearance is the desired. Now we will learn the type of histogram. There are three type of histogram: symmetric histogram. Here, left and right side are mirror image. I have prepared this histogram. This is the class of score 0, 10, 10, 10, 20, 20, 30, 30, and run scored by 2 clear, 3 clear, 4, 5, 4, 3, 2. So this is I have prepared on Excel sheet histogram. If you see the center point, this is center point. Both the side of histogram are the mirror image. If there is a mirror image, that is called as symmetric histogram. If this histogram midpoint join with a smooth curve, then it will become a polygon. It will become a polygon. This is the polygon. It is called a normal polygon because there no skew is there. Both sides is a mirror image. In this case, mean, median, and mode are equal. If mean, median, and mode is equal, then normal polygon graph will be made. Many times one number MCQ is coming in normal at the time of no skew histogram or polygon. What is the condition mean, median, and mode? In this condition, mean, median, mode are equal. Now, skewed histogram. Skewed to right side. If we skewed to right side, tail extend to right is called a positive skewed histogram. You see this diagram. If you see this is the right side, is the tail is extended to right side. This both side from the center, both side are not equal. So there is no mirror image. Right side is more. So it is called a positive skewed histogram. And say, if we join center point of histogram and made a curve, then polygon will become. This is called a positive skewed. This is the positive skewed. Here mean, if you have seen in our example, in first example, mean was 68.57. Mean is the greater than the median, and median is the greater than the mode. You refer this example that cover this type of polygon. Mean is greater than median, and median is the greater than mode, that is called a positive skewed. And many times MCQ is coming at the time of positive skewed. What will be the condition? Mean, median, and mode. Skewed to left side, tell extend to left. Here center point of histogram, left side is more, right side is less. This is called negative skewed histogram. Tell extend to left side. On this histogram, we will prepare the one polygon curve to joining the midpoint. So left side is the more extended. So it is called a negative skewed, and curve will be like this. Here mean is less, mean mode is greater than median, and median is greater than the mean on, on negative skewed histogram or polygon. In summary, we can tell if it is symmetric, even shape mirror image, mean, median, and mode are equal. If positive skewed, tell to the right, mean is greater than median and median is greater than the mode. Negative skewed condition, tell to the left side, mean is less than median, median is less than mode. If a uniform, all bars of equal height, mean, median, mode are equal. Many times 1 mark MCU is coming only from this table. Symmetric, positive skewed, and negative skewed. What condition will be there? Mean is greater than median, and median is greater than mode in positive skewed. Remember this table, first 3 points. Now we will move next graph, that is called a cumulative frequency distribution, OGIV. This is called a OGIV. This is a cumulative frequency distribution. Definition: an OGIV is a curve that represents the cumulative frequency distribution. Any curve represents the cumulative frequency distribution. That curve is called a OGIV. It is created by plotting cumulative frequency at the upper boundary of each class and then joining this point with straight line. The purpose is an OGIV is to show the cumulative total frequency up to each class interval. So there are two type of OGIV. Two type OGIV. One is the less than OGIV, and second is the more than OGIV. In less than OGIV, this type OGIV is plotted by taking the cumulative frequency at the upper boundary of each class. More than OGIV, this type of OGIV is plotted by using cumulative frequency from the upper boundary of the previous class. More than OGIV में upper boundary will be taken on the previous class interval. Remember this point. Uses of OGIV: finding median. The median is the value corresponding to the 50% cumulative frequency. First, draw the graph less than OGIV, mark the 50%, and that mark 50% cross point is the give you direct median. Or draw the graph of more than a OGIV and mark the 50% cumulative frequency. At that cross section of point will give the median of the graph, median of the class. Otherwise, you can overlap less than OGIV graph and more than OGIV graph. Crossing point between that is give a OQ point, that is called a median point. Median, that is the median. OQ point is the median. Analyzing and second uses of OQ, analyzing distribution helps in understanding the distribution of data and can show trends over time. Comparison of data set OQ allows the comparison of multiple distribution. Now with the diagram, we will understand less than OQ and more than OQ, how it is drawn. I will explain you. I have done this on the Excel sheet. This is the class, yeah, group 0 to 10, 10, 10 to 20, 20 to 30, 30 to 40, 90 to 100. Your 0 to 10 frequency is the 9, 10 to 20, 16, 17, 13, 11, 4, 7, 9, 6, 8. This frequency is the given. Now we have to calculate the cumulative frequency. 9, 25, 42, 55, 66, 70, 77, 86, 92, 100. This is the less than OQ. In less than OQ, here you take less than 10 value is the 0. 0, 10, here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And accordingly, you mark the cumulative frequency 9, 25, 42, 55, 66, 77, and 92, 100. Now you take a graph and plot it. Mark the class limit on x-axis and frequency on y-axis. Here market 20, 40, 60, 80, 100. Maximum is the 100. And frequency is also maximum is the 100. 0, 20, 40, 60, 80, 100 and 20. And you mark it. First is at 10. 10 frequency at 10, 10 class limit. Frequency is 9. 20 class limit. Frequency is the 25. 40 class limit, frequency is the 55. You mark a dot point and join all the dot with the straight line. This is called a less than OQ graph. How to draw more than OQ graph? More than OQ. This is the class and this is the frequency given. And this is the class limit. It is more than 0. Here mark 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now here mark total of frequency. Total of frequency is 100. 100 minus 9. Cumulative frequency here is the 91. From 91 minus 16 is 75. 75 minus 17, 58. 58 minus 13, 45. 45 minus 11, 34. 34 minus 4, 30. 30 minus 7, 23. 23 minus 9, 14. 14 minus 6, 8. 8 minus 8 is 0. This is the for more than. Now you first mark at 0 class limit. 0 class limit, it is coming. Cumulative frequency is 100. And then 20 is coming 75. Then 40, it is 45. At 60, it is 30. Accordingly, you mark all the point and join it in a straight line. If you take this 50%, 50% of cumulative frequency, 50% cumulative frequency, you will get 36. You can calculate this median from the graph. From less than OQ, median is coming 35, here 36, so median is the same. And also, if you plot overlap this graph less than OQ and more than OQ, if you overlap this graph here, then this point is the OQ point. OQ point give you directly the median. This is the median. If there is a large data, more than 5,000, 10,000, and want to calculate the median, you can calculate the median with the help of OGU, you can calculate with the less than OGU, you can calculate more than OGU, or overlap each other and crossing point will the median. Then you understand by table also. Definitely represent cumulative frequency for value less than of given data point. Represent cumulative frequency for value greater than given data point. Cumulative frequency is the calculated by adding frequency from the start of the data. Cumulative frequency calculated by subtracting frequency from the total frequency. From the total frequency, we have subtract the frequency of previous class. Remember, in more than cumulative frequency is subtracted from the previous class. Graph direction, ascending curve, moving upward direction is less than OQ, it will move upward direction. If more than OQ, it move from downward direction. Descending curve moving downward as value increase. The benefit of OQ, easy to find the median. So how data add up. Good for comparing data sets. Helps understand data distribution. Better visual than a table. From table, it is very difficult to understand the median. From diagram, from graph, you can easily find the median. Useful in valuation report. Valuer can use OGI to present frequency and trend of price, age of property, and asset performance over time. So hope we have completed till time. Data classification, processing, graphical representation of data, frequency distribution, measure of central tendency, dispersion, and skewness. We have completed this. From this, minimum 1 mark, one question will come. And we will learn in our next video, which is planned, is coming in next week. In that video, we will learn probability, simple test of significance, correlation coefficient, and regression and correlation, time series, and index number. I will try to complete statics in next video. Thank you very much. In next video, we will do practice of MCQ. If you want PDF copy of this study material of statics, please mail to me at rajeshharisewa@gmail.com. I will send you free of cost this PDF study material. Thank you very much for watching this video on general all subject. I hope you found it useful and informative. Please share your valuable comments on YouTube so I can continue to improve the contents as per your requirement. Do not forget to subscribe the channel Hari Seva IBBI Valuation Cracker and support us with your feedback. See you in next video. Thank you. Thank you very much. I am requesting you, please subscribe this channel and hit the notification bell so that you will get my next video information, and share the video to your friends. Thank you very much.